Am I audible? Hello?
Yes,
Yes, sir.
Okay. This screen is visible to you?
Yes, sir. Yes, sir.
So in the last lecture, we will discussing about the reliability, that is attributes of the protection system. So what do you mean by reliability? Reliability is actually the ability of power system to operate properly during the period they are in service. So ability of the power system to operate properly during the period they are in service. Or you can say that for ability of power system to operate properly during their operational life or lifespan. You can also say operational life or lifespan. And reliability is inverse of probability of the failure. It is inverse of the probability of the failure, and the reliability can be the dependability or the security or stability. It is further divided into the dependability and stability or security. So, what do you mean by dependability? It is we can say that the dependability is actually it is the certainty of the correct operation in response to the system trouble. You can say that when the fault occurs in the system, then a device must be capable to operate. So, if you can say, if you take the case of the relay, a relay is said to be dependable if it trips only when it is expected to trip. So, dependability is related to the expectation. That is, it is a relay is said to be dependable if it trips only when it is accepted to trip, and this happens either when the fault is in the actually in the primary jurisdiction or when it is called upon to provide the backup protection. That I have already told that whenever the relay is used, so it can also act as a primary protection, and for the backup protection detail we can discuss when we are discussing the detailing of that. So, however, the problem arises. There is also the false tripping of the relays are tripping for the faults that are not in the jurisdiction of that. Let us consider the system. Let us consider a system transmission line, and let us suppose the relay is there, one and the two relays there. However, third line is also there, and let us suppose that this relay, it is acting as the primary relay for this line. It is acting as an backup relay for this line. It provide the backup. There is time delay in between the two. However, it is not providing the backup for this line. So it is not intended to protect this line. However, there are suppose that this relay trips because of the fault in this line. So it is not required because it is not easy in its jurisdiction. So it is, you can say that it is a faulty operation from the system operation point of view. And as a result of that, the power system may get stressed out, and there can be the loss of the service because we have not used this relay for the protection of backup protection of this line. However, if it trips because of the fault in this, then the system is interrupted because of that. So dependability is the degree of certainty that the relay will operate correctly. And if we quantify the dependability, then the dependability is given by, this dependability is equals to number of correct trips divided by number of desired trips into 100. So dependability is the number of this correct trips divided by the number of desired trips divided by this 100 into 100. And it can be, this dependability can be proved by increasing the sensitivity of the relaying system. That is, the relay must be sensitive to the task for which it is intended. Now, second one is the stability or the security. Second one is the stability or the security. Now, in case of a security, if any misoperation occurs, stability or the security, if any misoperation occurs, then system should remain stable. That is, if any misoperation occurs, then system should remain stable. And if you see the security, it is given by this quantified as the number of correct trips divided by the number of trips. So the security is given by number of correct trips divided by number of trips into 100. So this is the security. And you can say that security is used to characterize the false tripping in the relays. And the relay is said to be secure if it does not trip when it is expected to trip. And it is the degree of certainty that the relay will not operate correctly. So false trips, if you see that false trips will create the nuisance for whole of the system and compromise the security of whole of the power system. Let us suppose that you have a two area system. Then if the fault occurs in that tie line of the system, then in that very case, the whole of the system will be in danger, because we are not providing, because frequency is affected because of that. So these, if you take the case of the security and the security and the dependability, both are contradictory, and however, we have to strike a balance between the two. So dependability and the security are contradictory, and we have to strike a balance between these two. Between these two. Now, the next attribute is the economics. Next attribute is actually the economics. So the next attribute of this protective system is the economics. So what we do whenever we are building the system, we will try to get it economical. We can get the maximum features with the minimum cost. That is, we have to optimize it. Maximum features with minimum cost. That is what we have to do. We have to optimize the protective system. Like if you see that nowadays, whatever the relay we have in our lab, also whatever this, we have the microprocessor based relays. So we have recently purchased these microprocessor based relays, which are used in the industries, and it is also in the lab. We can, whenever we can start the lab, I will share the all the details of that with you, when at least when you know the basics, so that you can understand it well. So those microprocessor based relays, these relays can act as under voltage, over voltage, under current, over current, every type of the relay it can act by using some program. By writing the program in that, it is already programmed. So we have to select that, and from that we can select which type of operation is required. So we are getting the maximum features. However, it is very costly, but still we will try to get the maximum features with the minimum cost. That is related to the economics. However, this is related to case basis. Let us suppose that if the total cost of the system is 100%, let us suppose that we want to protect the transformer, and if the cost of the transformer is 100%, then if we can have a table of that, we can see that what's the percentage of the cost of different equipment, then component and percentage of total cost. So we will have the relay. The cost of the relay is 0.54% of whole of the 100% of cost of equipment. Relay panels, it is 0.27%. Then we will have wiring, it is 0.11%. Then we have the relay room, 0.12%. and we have CT 3.10%, and PT it is 1.08%. And if you take the case of the total cost, it is of this protective equipment. It consists of the protective equipment. So the total cost is 5.22%. However, you can say 6 to 7%. However, it will not exceed any system, the protective system. This cost of the protective system will not exceed 10% of the cost of whole of the equipment. So 10% is required, that maximum 10% is the limit for this protective equipment. So this is about the economics. So we have discussed the various attributes of this protective system. Now, if we take the case of a small example, let us suppose that let us take a small example of the one more thing, reliability. We have discussed the reliability, we have discussed the dependability, security. However, if we want to quantify the reliability, so reliability can be quantified as this. We have used the security, number of correct trips divided by the number of trips, and the reliability is given by number of correct trips divided by number of desired trips plus number of incorrect trips. Now, let us take a small example so that we can all the formulas that has been this used here. We can have the overview of that. Now, the question is the performance of an overcurrent relay the performance of an overcurrent relay was monitored over a period of year and it is observed that relay operated 14 times out of which 12 are correct trips out of which 12 are correct trips, and if the relay failed to issue the trip decision, on 3 occasions, then we have to find the dependability, we have to find the security, and we have to find the reliability. As you know, the dependability is given by number of correct trips divided by number of desired trips into 100. So what are the number of correct trips? Number of correct trips are 12 in this case. And number of desired. What are the desired trips? Desired are 12 plus 3, where no decision occurs. So we will have 15 into 100. So it is 80%. And if you want to calculate the security, the number of correct trips and the number of trips. Correct trips is 12 and number of trips 14 into 100. So it is 85.71%. And if you want to calculate the reliability, then it is number of correct trips divided by number of desired trips and number of incorrect trips. So number of correct trips 12, desired trips 15, and incorrect trips 2 into 100. So in this case, the reliability would be 70.59%. So from this, you will observe that dependability and security are above 80%. However, the total reliability is less, that is 70.55%. Now, next is one more terminology that has been used in protection, if you see, is the unit protection and non-unit protection. Unit protection means that operates, that if this protection system operates for a fault in the particular zone. Let us suppose that we want to protect the equipment, and for that we use the differential protection. We can discuss that in detail. However, you must have some idea of that differential protection means that whatever the input is going to the transformer is equals to the output. If there is difference between the input and the output, then this signal is generated, and as a result our relay will trip. So it will take into consideration it will have the CTs on both the sides. It will measure this secondary current is measured, and it will be, we can see whether there is a difference in the current. If there is the difference in the current, let us suppose that fault occurs in the system, then if in between that, so what happens, whatever the current is flowing here is different from the flowing in the second CT, and as a result the difference is there, and as a result the trip signal is given to the relay and relay will operate. So this is the differential protection. So what is the unit protection? So it operates for a fault within its own zone. So the zone of the protection is this one. This is the zone of the protection. Zone of the protection is decided by the CT. So this is the zone of the protection. If you can say that this is the zone of the protection. So that the unit protection means that the relay operates for a fault within its own zone, and this zone of the protection is decided by the where we place the CT. Let us suppose we place the CT here, then the zone of the protection would be from here to here. Where we place the CT, the zone of protection would be from that. So this is known as the unit protection scheme, and because we want to protect the whole of the unit, so many of the equipments which are in which the unit protection scheme is used, these are actually the transformers, generators, induction machine, reactors in some cases, etc. So here we are using this unit protection scheme. So unit protection scheme that is intended to protect that particular unit. Now next is the non-unit protection scheme. So this non-unit protection scheme, the protection is obtained by grading the successive relays. It is not that is we cannot have the CT for that for a particular unit. What we do, we grade the successive relays, and depending upon that, what we do, we will protect our system. Like if you see that overcurrent and the protect this distance protection is actually done used for the transmission line, and overcurrent protection is used for almost whole of this equipments. So it depends upon then what type of protection we want. So this is the non-unit protection. Let us suppose that we want to protect the transmission line, and we have the relay. Here we have the relay. This relay we are using the this primary relay, and this we are using this relay. This suppose it is R1, so it is also used as the backup relay for this system also. So it is it means that protection depends on the grading of the relays. What we do the grading of the relays, and depending upon that, what we do, we protect our system. So this is about this different attributes of a protection system. Now, next we can discuss the zone of the protection. Then what are the different zones of the protection, and how these zones of the protection are actually uh, created. That how we can create because we have, if you see the system, we have the different protective system. So we want to create the zones on that protective system. So that we must have to create the zone so that the protection system should be such that no device is left out. Now, zones of protection. Now, let us suppose that we have a system, generator, then we will have bus bar, transformer. After that, we have again this again bus bar is there. Then transmission line is there. Then again after the transmission line, we will have the transformer. Then again bus bar. And let us suppose that we have another generator connected here. Now, what we do, we will create the zone of protection for the system. So it means that if we want to protect the generator, then in that very case, this is the zone of the protection for the generator. That is the generator zone of protection. Now, after that, we will have the bus bar. Now, the generator zone protection up to that. Now what happens? What we do, we cannot left any area to be unprotected. Like let us suppose that we have a generator and we have bus bar. So let us suppose what we do, we protect this generator, okay, and then we protect this bus bar. That is, we protect this bus bar. That is, its zone of protection would be. Let us suppose. Okay, I can again draw it. Let us suppose that we have a generator and we want to protect the generator. So it is the zone of protection of generator. Then we want to protect the bus bar. So it is the zone of the protection of the bus bar. So this is left out. And if the fault occurs in the system, then definitely it would have severe effects on whole of the system. So what we do, that the adjacent zones must overlap. It means that the adjacent zones of protection must overlap. Like this is the zone of protection for generator. This is the zone of protection for, you can say that bus bar, that is adjacent zones must overlap. This is the zone of protection for transformer. This is the zone of protection for again bus bar. Again, this is the zone of protection for transmission line. It is again so overlapping. This is the zone of protection for bus bar. This is the zone of protection for this transformer. This is the zone of protection for bus bar. Again, this is the zone of protection for another generator. So what, this is the generator zone, this is the bus bar zone, this is transformer zone, this is again bus bar zone, transmission line zone, again bus bar, then transformer, bus bar, and this generator zone. So it is seen that the adjacent zones, these overlap. However, if we don't do that overlapping, then what happens? Some of this part, it remains unprotected, and that is not required in this case, because we must want that zones must be protected. And how that zones can be provided, it is provided by where we have installed the CT. Where we have installed the CT, where we have used our CT. Now suppose, let us suppose that we have a system like here, then we have the double circuit transmission line, and let us suppose we want to protect the system, then we have used CT here and secondary CT here, CT here, and CT here. Now the zone is created where the CT is located. Now the CT is located here, and as a result we can say that this zone is created. So whole of the zone is created because CT is located here. So it is the CT which decides that how, where the zone is created, because it is the CT is simply it is nothing but we are getting the information from this CT. From current transformer we are getting the information, and if we want the information from, suppose at these zones are overlapping, we want the information from here, so we have to place the CT here. We have not if we place the CT here, suppose we place the CT here, one CT here and another CT somewhere here, so in that very case it will get the information from here only, but it is not good as per the protection system is concerned. We have to overlap the zones. So what we do, instead of taking the CT here, we place this CT here, and as a result the zone of the protection is created because of that. So the zone of the protection must be overlapping, that it must not be, you can say, so that the system will not remain unprotected. However, at the same time, we have to take into consideration this fact that if the fault takes place in the overlap zone, let us suppose that if the fault takes place in the overlap zone, then minimum number of circuit breakers should trip. That is, minimum number of circuit breakers should trip. That is, if the this fault takes place in this overlapped zone, minimum number of circuit breakers and this should trip, causing the however, if it trips, if the maximum number of circuit breakers are tripped, then definitely it will affect the whole of the systems. So each of the zones can be implemented by different relaying principles. Sometimes we are using the different relays for this for the implementation of a different type of zones. Like if you see the bus bar, if you take the case of the bus bar, because the ends are near, so we are using the differential protection. However, for the this transmission line, we are using the distance protection. So all the zones in this case, you cannot say that these are perfectly marked out, and however, the zones keep on expanding or contracting depending upon that what are the system conditions. So it also keeps on this contracting and you can say expanding depending upon this system condition. So from this you will see that how the system this how the protection system is so complex that we have to take into consideration all these factors, that is overlapping zones are contracting and expanding. So these things we have to take into consideration. So it is very complex system, and we have to take into consideration all these facts. Then whenever this fault occurs, then minimum number of the circuit breakers would trip. Otherwise, there is a, you can say, there is a problem for the whole of the system. Now, next we can discuss about the this CT and the PT. So, can anyone can tell me that what is CT and PT? Can anyone tell me?
Current
Current
transformer and
transformer, potential transformer.
potential transformer.
Okay, we can continue, or we can continue in like next lecture.
Sir, next lecture.
Okay. So, tell me the questions related to that, so that we can have some discussion.